we have discussed HVAC machines first class. Means vapor compression systems we have discussed. Correct. Then what all things we need to create comfort for the people. What all things we have to take care. Type of air conditioning system. These things we have discussed. Now we can move to type of air conditioning machines. DX type, direct expansion machines and chilled water machine. Below direct expansion, we are having like a 4 or 5 types of machine. Below chilled water also, we are having different machines. First, we can start with the direct, whether there is DX type or chilled water type. The major difference is, if you are using a refrigerant to cool the spaces, that is called the DX machines. Directly, the refrigerant will be coming to the indoor coils. Then the refrigerant will be expanding within the indoor coils. Accordingly, it will be cooling the air. Then we will be getting the cooling comfort inside. That is called a DX machine. Then the chilled water means by the help of vapor compression system, refrigerant will be there in chilled water as well. By the help of vapor compression system, refrigerant, we will be cooling water. That water we will be circulating through the building to cool the air. So instead of all the indoor AC, all the indoor equipments or low side equipments, instead of evaporator coil, there in chilled water equipments, we will be having a cooling coil. And in inlet connection and outlet connection, we will be having a set of valves. Okay, then we can study. We can start with the DX first. Direct expansion machine. The cooling medium is a refrigerant. The conventional vapor compression system. All the indoor equipments or the cooling equipments will be having evaporator coil, compressor, condenser, expansion valve, and evaporator coil. So the refrigerant will be directly expanding within the evaporator coil. Accordingly, we will be getting the cooling effect within the spaces. That's why we used to call that as direct expansion machine. Refrigerant will be directly expanding within the evaporator coil. So accordingly, we will be getting cooling comfort when we are circulating a room air through the evaporator coil. Accordingly, only we will be getting the cooling effect. Okay. Direct expansion machine, the first type, we are having like a split AC, multi-split AC, unitary equipments, VRV, VRF equipment, and DX, AHU, and FAHU. One by one, we can discuss. The first we can discuss with the split AC. Name itself, it is there like a splitted. Means vapor compression system has splitted by 2 parts. One outdoor unit, one indoor unit. So split AC means one outdoor unit, only one indoor unit will come. One outdoor unit, multiple indoor units are coming means there is not split AC. Split AC, one outdoor unit, only one indoor unit. Outdoor unit, we will be having compressor. Then and condenser. Compressor, condenser plus condenser. Fan is also there within the outdoor unit. Indoor unit, we will be having expansion device and evaporator coil. Depends. Expansion device and evaporator coil will come in the indoor unit. Most of the equipments like expansion device will be very close to the evaporator coil. So that will come near to the indoor unit. Okay. So split AC outdoor is this one. Split AC outdoor, we have witnessed. Correct. This is outdoor unit. Outdoor unit, this is our compressor. Correct. What is this one? Accumulator only. And here you can see your condenser. We have discussed all these things in the first session. The condenser fan will also come. And these are outdoor unit and these are indoor unit. Correct. This is our indoor unit. Indoor unit will be having evaporator coil here and we'll be having a blower fan there. Correct. Blower fan. So what the blower fan will do? The blower fan, when it is taking the return air will be coming from the top side only. Okay. Let's say the return air temperature will be 26 degrees Celsius. So there is 26 degrees Celsius of air will be circulated through the surface of evaporator coil. So within the evaporator coil, the refrigerant will be circulated. The refrigerant will be absorbing heat from this 26 degrees Celsius of air. So the air temperature will be decreased to nearly 13 or 14 degrees Celsius. Using this 13 degrees Celsius, we can cool the spaces, right? Means this 13 degrees Celsius of air will be mixing with the existing hot air within the space. Accordingly, the temperature within the space will decrease. So this is your indoor unit. Between indoor unit and outdoor unit, we will be having a refrigerant piping. Correct. This is your outdoor unit. Between outdoor unit and indoor unit, we will be having a refrigerant piping. Okay. Anyhow, type of outdoor unit remains same, but type of indoor AC indoor unit will vary for the split AC. For example, split AC outdoor unit will be having compressor, condenser fan in common. Yes, then PLC board, capacitors, then motor, capacitor can come, accumulator. There is other, it's not a part of vapor compression system. Like major in outdoor unit will be having compressor and condenser plus condenser fan. But outdoor unit, the type of outdoor unit may vary. Sorry, indoor unit. Outdoor unit remains same. Type of indoor unit may vary. Wall mounted, floor mounted, ceiling mounted, ducted type. Means indoor unit we might be hanging on the wall, or we will be we'll be placing on the floor. Then we will be hanging on the false ceiling, or it might be concealed above the ducted ceiling, concealed above the false ceiling like a ductable one. One by one we can discuss. The first one, wall mounted split AC. That's a conventional split AC that we are using for residential applications. Normal type. Correct. So if this is your finished floor level, FFL, okay, and this is your false ceiling level. As you know, the normal height from the finished floor level to false ceiling level is how much? 2.7 meter. Normally, the split AC, the bottom of split AC, normally we will be placing at a height of 2.4 meter. Mounting height. And also in the top side, minimum 6 inches means 150 mm. Gap has to be there. If it is not there, means accordingly, means false ceiling height fixed on the 2.7 meter. If you're not getting enough height above the machine, when it is taking the return, so the returner will not be getting enough space to get into the building, get into the machine. So the recirculation of air will not be completed. So the machine will not be able to identify the room temperature when it is increasing or decreasing. That's why there should be enough space above the false ceiling. If the machine is taking the return, normally split AC, wall mounted split AC will be taking return from the top side only. Then it is circulated through the surface of evaporator, then it is delivering through the front side, through the vent. So minimum manufacturer in the technical data sheet, they will mention from the return side, what is the minimum distance has to be maintained. Correct. So here at least means 6 inches means 150 mm has to be maintained. Okay. For the proper recirculation of return air. Mounting height. Okay. See how it is working normally. Initially, this is your split AC. Correct. And this is your outdoor unit, and this is your indoor unit. Indoor unit. Let's say atmospheric temperature in the starting might be like 38 degrees Celsius, atmospheric. So temperature inside the space might be like 5 degrees Celsius, less than that you can. This is approximate value. Let's say 33 degrees Celsius. So initially, once you turned on your AC machine, and you have set with a temperature of 24 degrees Celsius. Okay, what will happen? The machine will start. Initially, when the coil will remove the latent heat, we have studied. Initially, the coil will remove the latent heat. Then eventually, the room temperature means once the AC has started, it has to take 2 heat. Once the AC is starting, it has to take 2 types of heat from the space. The first one, heat that is existing within the space, because this is already having a temperature of 33 degrees Celsius. From 33 degrees Celsius to 24 degrees Celsius, the temperature has to be decreased. That's why existing heat has to be removed. At the same time, each second, a certain amount of heat is generating within the space. Heat that is generating also the AC has to take care. Normally, AC we will be selecting for generation heat only. Each second, how much watts of heat is generating, according how much joules of heat is generating, accordingly only we will be selecting the AC machine. So initially when it is starting, latent heat will remove, because the surface temperature of cooling coil is too less, somewhat near to 13 or 14 degrees Celsius. So the surface temperature of cooling coil is less than the dew point temperature of room condition. So this room temperature, this higher temperature room air is touching the cooling coil. Since the coil surface temperature is higher than or less than the dew point temperature of room air, initially condensation will start. Means from the AC, water will drip. Eventually, for 24 degrees Celsius, 50% relative humidity, each kilogram of air should have nearly 9 grams of water, right? That's a humidity ratio as per the ASHRAE. So once it has achieved, the condensation will stop. condensation will stop. After that, the room temperature will start increase. Until the humidity ratio is achieving, we can't witness a big change in air. From 33, initial temperature might be 33 degrees Celsius. Then from 33, 32, 31, 2 or 3 degrees Celsius of temperature difference only in the starting we can find. But once the humidity ratio has achieved, after that no longer condensation will happen. Then the room temperature will start increase from 33, 32, 31, 30, 24. Okay. Once it has achieved 24, on the surface of your split AC, surface of this indoor equipment, we'll be having a room temperature sensor. This one. You can see there is a room temperature sensor has mounted on the surface of evaporator coil. So by the help of this room temperature sensor, the sensor will identify the temperature. Okay. Now the temperature has achieved room temperature. What will happen? The signal will be going to the compressor. Your compressor and the condenser fan will shut down. It will not working because the temperature has already achieved, right? But after some time, you can see if there is compressor is not working, there is no flow of refrigerant through the system. So the refrigerant is, or the indoor unit is not extracting any heat from the space. Already we have achieved 24 degrees Celsius, but if the compressor is not working, then the room temperature will start increase. From 24, it will be increasing to 25, 26, 27. So once it is start increasing, the compressor will identify by the help of temperature sensor, then the compressor will start again. That's the way the normal split AC is working, not the inverter AC, split AC. But one thing, as I told, once you have achieved the set temperature of 24 degrees Celsius or 22 degrees Celsius, your compressor will stop working, condenser fan will start working, but even though the blower fan will work. Indoor AC, we will be having a blower fan. Why? Because once the temperature has achieved 24 degrees Celsius, your outdoor unit will stop working. Indoor unit has also stopped working. You can imagine after some time, anyhow, since the compressor is not working, your room temperature will start increasing from 24, your set point. So the indoor unit has to identify that, or the system has to identify. So the system is identifying that the temperature fluctuation by the help of temperature sensor only. So if the blower fan is not working, means there is no air circulation through the temperature sensor. So once the compressor has stopped working, after that there is no extraction of heat from your space, the room temperature will start increasing from 24, 25, 26, 27. Now the compressor has to start again. But if the blower fan is not working, since we are not having no air circulation through the temperature sensor, through the indoor unit, the system will not be in a position to identify that. So whenever the room temperature is start increasing from the set point, the compressor will be not in a position to start because the temperature sensor is not identifying it. That's why once the temperature, yeah.
Excuse me, sir, the compressor will start at 25 only, or it will wait till the match up with the ambient temperature?
I will explain that. Okay. Let me finish it. I will explain. Okay, so that's why even if the compressor and the condenser fan is not working, once the room temperature has achieved 24 degrees Celsius, then your blower fan should work. Not for big speed, because most of the indoor equipments now we can adjust with the minimum 3 speeds. Speed number 1, 2, 3, right? Okay, that's why sometimes it might be automatic machines. If you are having, means bigger machines will be automatically decreasing. Split AC and all, we are not having that provision. But big machines will be automatically decreasing the fan RPM. Okay, anyhow, he was asking, like, since we have set with the 24 degrees Celsius, on what temperature the compressor will start again? See, normally most of the manufacturers will be, you can imagine, just 0.1 degree Celsius is the throttling range we are providing. Means, if you are sitting with the 24 degrees Celsius, if the allowance is 0.1 degree Celsius, means once 23.9 degrees Celsius has achieved, your compressor will shut down. And 24.1 degrees Celsius has achieved 1.1 degree Celsius difference, your compressor will start again. But this 0.1
1 degree Celsius of temperature fluctuation is very difficult to sense by the help of a conventional sensor. And also, on-off cycle of your compressor will be too high because it is just 0.1 degree Celsius now. Suddenly 23.9, your compressor will start. Suddenly the temperature will be reaching to, once it has achieved 24.1 degree Celsius, your compressor will start. Suddenly the temperature will be decreasing into 23.9 and it will stop. So this very less temperature fluctuation, no, this allowances, your on-off cycle of your compressor will be very high. That's why manufacturers will be keeping some allowance in the control panel. There is a program logic control. The control board will be there. In that, in the integrated circuit board, in the controller, they will be placing, in the program, they will be keeping allowances. Depends, plus or minus 1 degree Celsius or minimum plus or minus 2 degrees Celsius of allowance, they will be keeping there. Means if your set point is 24 degrees Celsius, AC will shut down once the temperature has achieved 22 degrees Celsius. AC will start again once the temperature has reached 26 degrees Celsius. Plus and minus 2 degrees Celsius of allowances, manufacturer will be keeping there. But sometimes it is plus 1 degree Celsius. We might not be knowing that. We might be thinking the temperature is 24, but actually the on-off cycle of compressor has adjusted by this plus or minus allowance only. Okay. Clear. So whether the AC will start at least around 24 degrees Celsius or 26 degrees Celsius, that is totally depending upon the allowance it has set by the manufacturer. Correct. Plus or minus 2% allowance, most of the manufacturers will be keeping, my knowledge. Okay. Okay. So that's the way it is working. See, in between outdoor unit and indoor unit, what all connections will come? So remember, normally electrical power point where we are providing. Electrical power point near to the outdoor unit we can place in the bottom or we can place in the top side as well. Doesn't matter. Okay, I will explain that. Anyhow, see, power point where we have to provide near to the indoor unit or near to the outdoor unit. Depends on the make. Depends on the make only. Normally, like Panasonic, Daikin, Mitsubishi, some manufacturers, the main power socket we have to provide near to the outdoor unit only. Then from outdoor unit to indoor unit, the control wiring will come. Control wiring. But other makes, indoor unit only will be providing the power connection. So from the socket, the power will be going to the indoor. From there, it will be going to the outdoor. Whether you are placing your socket, whether in the inside or outside, doesn't matter. But the problem, the manufacturer is recommending the socket in the outside, but you have accidentally proposed in the inside. But from inside to outside, if you want to provide the connection, we have to extend the cable. So cable extension, additional joint has to be done. That is not the proper way of installation. So that's why, with respect to the make, the power connection has to be provided whether in the inside or outside. That is not constant. It will vary. Anyhow, between indoor unit and outdoor unit, 4 connections can come. The first one, refrigerant connection. Correct. Indoor unit to outdoor unit, 4 pipes, 4 connections can come. The first important connection is refrigerant connection only, this one. One is a bigger pipe, the next one is a smaller pipe. As you know, one pipe is from outdoor unit to indoor unit only, that is going inside. The second pipe is from indoor unit to outdoor unit. We know after the condenser, from the compressor, then it is going to the condenser. After the condenser, the phase of the refrigerant will be liquid only. That liquid refrigerant will be going to the expansion device. Then it is expanding within the evaporator. Then the refrigerant will be evaporating by absorbing the room heat. That's why outdoor unit to indoor unit, normally liquid only will be traveling. Correct. Then from indoor unit to outdoor unit, after extracting the room heat, the liquid refrigerant will be evaporating to the vapor, or sometimes with respect to the heat within the space, it might be superheated vapor. If it is getting excess heat, it will become superheated vapor. That vapor only will be coming back to the outdoor unit. See, which one is? See, this is your indoor unit to outdoor unit. Smaller pipe, this is called a liquid line, or we used to call that as discharge line, or delivery line, or high side line, or high pressure line. Different names we are having. high pressure line. So pressure in the liquid line, that is similar to compressor delivery pressure only. With respect to the type of refrigerant, the compressor delivery pressure and the suction pressure ranges will vary. But irrespective of capacity, whatever the ton, for example, if you are using like R410A as a refrigerant, sometimes the delivery pressure might be 42 bar, suction pressure might be like a 15 bar. Whatever the capacity of the AC machine, it may 1 ton, 2 ton, 10 ton, the pressure ranges remain same, but the amount of refrigerant that we are having within the loop will be, mass of refrigerant will increase. Pressure ranges is totally depending upon the type of refrigerant only. Okay. So the pressure that we are having at the liquid line, this side, this valve, this is called a service valve. This is called a service valve. So in the liquid line, when you are checking the pressure, that pressure is called a liquid pressure or high side pressure or delivery pressure. Pressure that we are having means this is vapor line. This vapor line means indoor unit, outdoor unit. This one is called a vapor line, VAPOR or VAPOUR. Vapor line or suction line. Okay, suction line or low side line or low pressure side. Low pressure. Okay. These are the terms actually. But normally when we are saying pressure we are having in the liquid line is called high side pressure or delivery pressure. Pressure we are having the suction line is called suction pressure or low side pressure. But when the system is not working, when the system is working, in the high side you will be having 42 bar. When the system is not working, you will be having 15 bar. Okay. The suction pressure, sometimes we used to call that as back pressure. One more pressure is also there, standing pressure. What is standing pressure? When the AC is not working, the compressor is not working, when you are taking the measurement from this high side or this low side, that pressure is called standing pressure. Means if the system is not working, what pressure you are having within the loop, that is called a standing pressure. Okay. So high side pressure, low side pressure that you will be getting when the compressor is working only. When the compressor is not working, what pressure we will be getting within the loop, that is called a standing pressure. Normally technicians will be using this one. With respect to the standing pressure, they will be finding the saturation temperature. Accordingly only they will be finding, suppose whether there is any leak of refrigerant and all, we can find. We can study in the filling time. Okay. Fine. Okay. So what might be the diameter of this one? In the design class, see, VRF system or multi-split AC, from outdoor unit to indoor unit, we might be having more than one indoor units. There we have to go to the technical data sheet with respect to the capacity index and all, we have to size it. That is a different topic only. It's a long topic. In the VRF refrigerant pipe sizing classes we can study. But this standalone system, individual split AC, one outdoor unit, only one indoor unit will come. Then what about this pipe diameter? Normally, when you are purchasing split AC, you don't want to purchase the pipe. Correct. Minimum 3 meter to 7 meter with respect to the manufacturer. 3 meter, at least vapor pipe and liquid pipe you will get. But what is the restriction? What might be the distance between outdoor unit and indoor unit? There is not a constant value. With respect to the type of manufacturer and the capacity of the compressor, it will vary. I will show that. For example, I am dealing with a split AC. The same machine that we have used in our drafting classes to prepare the model block, no? The same I am taking FDMRN 50 AV1K. The same we have used in our drafting session. Okay, FDMRN 50 AV1K. That was our model. Clear. In the drafting session, we have discussed that. What IC we have used? Final sheet. This one, correct. This was our project in the drafting class. Which one we have? FDMRN 50 AV1K only we have used. So if we are going to that make model number, FDMRN 50, just go down. The technical data sheet, the connection details, refrigerant details you can find. This is cable size only. Power supply cable, just below. Okay, FDMRN 50 AV1K. What's the liquid pipe size? That is 9.53 millimeter. Sometimes it might be in millimeter, sometimes it might be in inches. Okay, 5 by 4 inches, 1 by 4 inches, different inches also it can come. Liquid line is 9.53 millimeter. Gas pipe is 15.88. Manufacturer has provided. And what is the distance between outdoor unit and indoor unit? This is your outdoor unit and this is your indoor unit. Okay. From indoor unit to outdoor unit, I will be connecting the refrigerant. Maximum allowable length means this is, let's say this is length A and this is length B. So A plus B, total length should be, maximum allowable length should be, for this model that is 50. This model that is, it should be less than 50 meter because it is a high capacity machine. If it is a less capacity machine, sometimes it might be 7 to 15 meter. Okay, this is A plus B. But what is the maximum B, vertical height between outdoor unit to indoor unit? That is 30 meter. Vertical height should be 30 meter. For all this model, that is 50 and 30 only. But if you're going for other model and other manufacturer, the criteria remains same. So that's why split AC, whatever the split AC, individual machines, no, whether that is wall mounted split AC, floor mounted split AC, cassette AC means ceiling mounted split AC or ductable split AC, we don't want to do any specific calculations to select the refrigerant pipe. We have to go to the technical data sheet. From there directly we can find it. Okay, and what's the distance between outdoor unit, indoor unit, everything we'll be getting from there. But normally, this is like a ductable unit only, high static machine, high capacity machine. Normal conventional split AC that we are using in the residential, between outdoor unit and indoor unit, maximum permissible length is 7 meter, maximum it is 15. 7 to 15 meter only. Sometimes it might be less than 7 meter. It is not constant. You have to go to the technical data sheet of the manufacturer, then only we can find. Okay, but maximum for split AC, most of the manufacturers, we can go up to 15 meter overall, A plus B. Vertical 7 meter, like that it will come. But depends, it will vary. We can't simply by heart it, so we can't simply predict it. Normally, the distance between indoor unit and outdoor unit maximum within 15 meter, we have to place it. But some manufacturers means high pressure compressor machines and all, we can go beyond like this. Okay, the range we can increase in that scenario. Clear? Okay, so that's why the liquid line and vapor line diameter we can find from the technical data sheet, this one. And what material we are using here? The material that we are using, this one, no? Copper only, definitely. Any other material we can use? We can use, no problem. Aluminium we can use, but practically there is not cheap, lesser only, no, but if there is any damages, no, chance of leak will be more. That's why most of the machine, to connect indoor unit and outdoor unit, will be using which one? Copper only. Copper also, two types of copper pipes are available in the market. The first one is hard copper pipe. Hard copper pipe. This one, it is rigid only. It is not possible to bend it. Suppose if you want to join the pipe, then there we have to use pipe fittings, elbow, T joint, U joint, and all we have to use. So if you want to join the two pipe material, then the process of joining method will be bracing. BRIZING, hard copper pipe bracing method. Means type of welding only, by the help of like a welding gas, we will be melting the copper electrode, then we will be joining it, bracing. We are not using this one. This one we are using for VRF outdoor unit, to interconnect the outdoor unit, multiple capacity outdoor unit, then we are interconnecting parallelly. There we can use this hard copper pipe. Otherwise, we are not using this one. We are using soft copper pipe only. Soft copper pipe is flexible. This one, flexible only. This one, if you want to bend it slightly, you can't twist it like a rubber, it is not possible. But somewhat like ductility or ductility it is having this. Flexible only. So that's why. So type of pipe material, copper, soft copper only we are using. And if you want to join in two pipe, then the bracing only we are using, or this one. Here we are using a nut. We are having a nut there, no? This nut is called a flare nut. Flare nut. Correct. Make sure your mic is muted. Okay. Flare nut. This one. How we can connect the flare nut. For example, if this is your copper pipe, okay, like this only. Edge of copper pipe, they will be slightly chamfering like this. Means this is your copper pipe. Edge of copper pipe, they will be slightly chamfering like this. Then we'll be placing the flare nut inside. Correct. So here you'll be getting a tight sealing. Then the flare nut, we can fix in the service valve. There is a flare nut only. So the nut that we are using to connect your refrigerant pipe with outdoor unit, that is called a flare nut. So by the help of flare nut only, the copper pipe, we are joining in between. Okay. That's why this liquid line is smaller one, vapor line is bigger one. Okay. So both in India, like summer air conditioning countries, winter that is not mandatory for one line. Summer country, here no, both the line we should provide thermal insulation. Thermal insulation and insulation separate chapter in the design class we can study with respect to the resistance value and the climate zone, how we can select the insulation material and what should be the critical thickness of insulation. Everything in the design class we can study perfectly. Now for your knowledge, what should be the type of insulation material that we are selecting? Type of insulation material, the most common and reliable recommended material is nitrile rubber only. Nitrile rubber insulation. This one, nitrile rubber. Chilled water and all, we are using this one only. But PVC, insulation, you can see this kind of PVC insulation we are using in cable. Correct. But critical thickness matters. And the type of insulation that we are using is polystyrene is there. Polystyrene pipe. Pipe that is going to the underground tunnel and all, we can go for polystyrene insulation or we can go for calcium silicate insulation. Okay. Then we are having polyolefin. Okay. Polyolefin, this kind of polyolefin material is there. Okay. Polyurethane. Polyurethane pipe insulation. Duct also we are using the same material for duct also, polyurethane. PU foam we can use, duct also. Cheaper only. Okay. So most recommended material is what? Nitrile rubber only. Means flexible elastomeric insulation. Okay, nitrile rubber. Fine. Anyway, when you're purchasing this one, along with that, you will be getting the thermal insulation material, right? But additional, we can purchase it from the market. So that is the two pipe. In between indoor unit and outdoor unit, we'll be having liquid line and vapor line. Then like another one is control wiring, means electrical line. Definitely between indoor unit and outdoor unit, we should have a control wiring plus electricity connection. Then only the components will work. Indoor unit will be having a blower fan that need electricity. Outdoor unit we are having like compressor, condenser fan that also need electricity, right? That's why control. Then control wiring, because whenever you are setting the temperature, the outdoor unit compressor has to identify. But normally the main control panel will be coming here only. Here also we are having one. So to transfer the signals, no controls, we need a control wiring. Between outdoor unit and indoor unit, we'll be having control wiring. Then drain line also will come. Condensate. We used to call that as condensated drain line or condensated drain. Below this one, no indoor unit, here we'll be having a condensated drain tray. Condensated drain tray will come just below the evaporator coil. At the end only, we will be connecting this condensated drain pipe. Because when the AC machine coil is removing the room latent heat, from the vapor, the moisture will be going back to the liquid. That's why the water is producing. That should be, it is with respect to the humidity level within the space, more amount of water will be condensed. The humidity level within the space is less, the process will be less, right? So that's why in indoor unit, there should be one more connection called a condensate drain connection. This one, just below that you can see. This will be projecting outwards, but you can hide it within the cover, plastic cover. So we should connect this with the, which one? A flexible pipe or a rigid pipe. This water we have to take outside. Sometimes people might, just below that we'll be having a condensated drain plastic tray. So water will be accumulated on the tray only. When the air is having contact with the surface, condensation will happen when it is removing the latent heat. So the water will be condensed and it will be storing on the tray. Eventually it will be flowing, then it will be coming to this condensate drain pipe. From here, we have to take it outside. If you're having more number of indoor equipments, all the condensated drain, we can interconnect with the drain lines, common piping system, drain separate line we can provide. All this condensated drain pipe, we can club with the rainwater harvesting system, or we can club with the irrigation tank, or in the outside, we can provide a sock pit. There we can free discharge to the atmosphere, depends. But if you are using this water, there is pure only. Condensation of water from the atmosphere is rainwater. It is not having that much contamination. That is pure water only. But unfortunately, when this moisture that is present in the air is having contact with the cooling coil, on the surface of cooling coil and inside the machine, we are having a lot of contaminations. Dust particles are there. That's why this water gets polluted. If you are purifying this water, then you can consume this one. Purification means you have to do the sand filtration, activated carbon filtration. Then reverse osmosis is also mandatory. Depends on the quality of water that you are getting from the atmosphere. Anyhow, ROEs we can avoid. Just by sand filtration and all, we can make this water pure. Okay, anyhow, just another story. Normally in the residential homes, what we are doing, we will be free discharging. We will be taking this pipe outside, then we will be free discharging to the atmosphere. Okay, that's a fourth one. So when we are installing this, when we are installing your AC machine, we'll be making a hole. Through that hole only, we'll be taking the pipe connections outside. Sometimes when the service technicians are making the hole, they might be taking the hole like a straight. Okay, that is fine for taking the electrical connection or control wiring outside. But when you are taking the condensated drain pipe, it's by gravity only the water is flowing outside for normal this one. We are not having any condensated drain pump for this kind of split ACs, wall mounted machines. That's why when we are making the hole, a slight slope has to be provided like this. So when you are taking your condensated drain pipe, by gravity, since it is having a slope, easily it can flow outside. Otherwise, the chance of block will be high. Since you are not having enough slope there, periodically, okay, Ravi Shankar, no problem. Okay, understood. That's why, like, if you're not maintaining the proper slope, the contaminations will be accumulated somewhere here, no? So eventually the block can come, leak can come. That is another story. So instead of taking the conventional PVC flexible pipe, we can provide a rigid PVC sleeve there. Means if you want to take a 32 mm flexible pipe outside, a 50 mm before doing the plastering. But if you are having a clear understanding of what type of AC machine we are going to purchase, then we'll be getting a template for that AC machine. We can place that template on the wall. Then accordingly, the drain connection we can tab there. Before plastering it, instead of doing this unnecessary drilling on the wall or core cutting on the wall, if your intention is to take a 32 mm pipe outside, a 50 mm sleeve you can provide, PVC sleeve. Then you can close it by the help of end cap. Then plastering you can do. Then after, whenever you are planning to install your AC machine, you can simply open the end cap. Through that, you can take your pipe outside. So you don't want to cut your plaster. A lot of issues can come, no? If you are not providing sleeve in the starting, when the service technicians were drilling the hole, if you are having any electrical connection that is going through this way, they will cut it. The conduit and all, they will accidentally cut it. And they will not maintain the proper slope there. A lot of issues can come. Okay, but good service technicians will be always maintaining a minimum slope there. What is the slope value? Whether there is 1:100 or 1:200, it is not there. But condensated drain piping details we are having in IPC, International Plumbing Code. With respect to the ton of refrigeration only we are doing it. With respect to the ton of refrigeration, how much has to be done. So that I will explain now. But IPC is International Plumbing Code. It is not HVAC, but I will show that. So IPC we will study in the plumbing classes. Okay, International Plumbing Code. We can check their control. I'm searching that, my condensate drain pipe. This one. Condensate drain pipe, 1/4 inch per foot slope has to be maintained. That we can study in the design class. Okay, what should be the diameter of condensated drain? But this is not applicable for individual connection. Multiple, if you're having more number of AC machines, like a ductable units and all above the false ceiling, what we will do, all these machines we will be hanging above the false ceiling. This is my machine number 1. Let's say this is 5 ton of refrigeration. I'm having another one machine. Plan only this one. I'm having another machine, one more machine, one big AHU. This is like a 20 ton of refrigeration. This is 10 ton of refrigeration. This is like a 20 ton of refrigeration. This is 8 ton of refrigeration. So I will be having a common drain pipe. This pipe will be going above the false ceiling. And from all the machines, the condensated drain pipe I will be connecting there. Okay. Routing and all we can study in the plumbing class. Okay. So the slope will be this side. What might be the individual pipe diameter? For example, first one, 20 ton. Up to 20 ton of refrigeration, the pipe diameter is 3/4 inch. Correct. So this will be 3/4 inches. So this also 3/4 inch. This is 5 ton of refrigeration. Anyhow, up to 20, that is 3/4 only. No. So this is also 3/4 inch. But when it is coming here in this line, we are having 20 plus 5. The slope is this direction only. So water will be flowing this way. 20 plus 5. There we are having 25 ton of refrigeration. So above 20 up to 40, the pipe diameter has to be increased into 1 inches. So this will be 1 inch. And when you are coming here, this is 10 ton of refrigeration, definitely 3/4 inch. This is like 25 plus 10. There we are having 30 ton of refrigeration. Sorry, 25 plus 10, 35 ton of refrigeration. Anyhow, up to 40, this is also 1 inches only. 8 ton of refrigeration, 3/4 inch. Okay. 35 plus 8. So here we will be having 35 plus 8, 43 ton of refrigeration. Correct. Above 40 up to 90, the pipe diameter has to be increased into 1 into 1/4. This is 1 into 1/4 inches. When it is coming here, 43 plus 20, that is 63 ton of refrigeration. Up to 90, that is 1 into 1/4 inch only. Like that, from the starting point to this direction, the pipe diameter in the direction of flow rate, you have to increase it. Whether that is vertical or horizontal, drain pipe, condensated drain pipe, we are sizing by this way only. Okay, there is not that much complex calculation. Drainage with respect to the DFU we are doing, drainage fixer unit. That table number 701.1 and 1.2 we are using for that. That is different. That in the plumbing classes we can study. Correct. Okay. This is a way the multiple unit, if you are having above the false ceiling, all the ductable unit we will be connecting to the common pipe only. The pipe diameter accordingly we can calculate. Okay. Anyhow, these are in inches only. If you want to find that in mm, the type of pipe material, this one, type of pipe material, the proposed material by ASHRAE is Schedule 40 PVC plastic only. Below PVC plastic, Schedule 40 PVC plastic, we are having different pipe material. Schedule 40 is a number. If the schedule number is increasing, means the wall thickness of the pipe material will increase. Okay, schedule number. And this is called a nominal pipe size, NPS. Nominal pipe size or diameter nominal. Nominal pipe size is in inches, diameter nominal is in millimeter. It's a representative value only. In the chilled water session, I will explain the pipe schedule and nominal pipe size. Okay. Anyhow, the type of pipe material is Schedule 40. Below Schedule 40 PVC plastic, Schedule 40 PVC plastic, we are having different material called CPVC, chlorinated polyvinyl chloride. We are having UPVC, unplasticized polyvinyl chloride. We are having PPR, polypropylene random. We are having HDP, high density polyethylene. Then we are having ABS, acrylonitrile butadiene styrene. Different pipe material we are having. All these pipe materials are permissible, but the most common material that we are using is UPVC, PVC, UPVC and HDPE. If the condition